moving on to set theory. All right, so if I have this here means X is an element of A. So we've seen that little element sign before, right? Like this thing here. Okay, so this is the only time we use the 0 with a cross through it. So that means the null set or the empty set. All right, so this symbol here is different than element of. And I would need to make sure that you know the difference because it's going to be a big deal. I'm going to do tons of examples down here differentiating between subset and element of. So A is a subset of B. A is a subset of B, and this means if and only if. For every X that's an element of A, then X is an element of B. So I'm going to, excuse me, show this picture. So if I've got A here, this is the set A, then and if this was the set B, then A would be a subset of the set B. And then this is the simple kind of stupid case. If the set A is equal to the set B, then A is a subset of the set B. So you notice kind of like a less than or equal to. All right. So if I've got an element, oops, I forgot the comma there, didn't I? An element, or I'm sorry, a set that has these elements, 1, 2, and 3. This is how you would say it. So this is the set that has the numbers 1, 2, and 3 inside of it. Okay, so here comes the challenging part. I want you to work with me. So this set, right, if I put the little thingamajiggies on here, this set that contains the element of 2 is a subset of the set that contains 1, 2, and 3. Okay, this number 2 is an element of this set because 2 is inside. Okay, so okay, we're going to play with that a lot, so make sure you see that. So what would be wrong to say would be that 2 is a subset of 1, 2, and 3. The number 2 can't be a subset because it's not even a set. It doesn't have the parentheses, so this would be wrong, right? And I can't say that this set 2 is an element of this set 1, 2, and 3, right? Because this thing here, this set 2, is not inside of here. The element 2 is in here, but not the set 2, right? So I want to make sure you see the difference between these two, and these two are wrong. All right, so if we're taking a negation of this statement, so if I want to say A is not a subset of B, that means it's if and only if there is an element X that's in A that's not in B. So let me just draw some pictures of what this could look like. So this could be the set A. Oh, sorry, I went too small. I can't even draw the A in there. Here's the set A. Here's the set B, right? So this set A is not a subset of B. So that's one example. So let me do another example. The set A not being a subset of B, this could be the A, and this could be the B, where there's a little bit of an overlap, but there's not a subset. Or another example, if I had this case, A is not a subset of B, correct? A is not a subset of B. So these are just 3 pictures to describe that. We call A a proper subset of B if there's at least one element of B that's not in A. Oh gosh, look at all the typos. If there's one element in B that's not in A. So a proper subset, this right here would be a proper subset because A is not all of B. This is not a proper subset, right? A proper subset means that there's an element in B that's not in A. Okay, so now let's go do these examples. So I want you to answer yes or no, because I didn't even say what the question was here. I guess, yeah, I'm just asking questions. Yes or no? Okay, all right. Is 3 an element in this set 1, 2, 3? Yes. Is 11 a subset of the set that contains 11? No. 11 is an element of, right? 11 would be an element of the set that contains the number 11. Is the set 4 an element of the set that contains the numbers 3 and 4? No. 4 is a subset of 3 and 4. Okay, is the set 2 an element of the set that contains 1, the set 2, and the set 3? Ooh, yes, because this is actually inside here, isn't it? Is 1 a subset of the set that contains 1, 2, 3, 4? Yes. Is 1 an element of the set that contains the number 1? Yes. Is the set 1 an element of the set that contains 1? No. The set 1 would be a subset of the set that contains 1. Is the set 1 a subset of the set that contains the set 1? What? Let me say that again. Is the set 1 a subset of the set that contains the set 1? No. The set 1 is actually, I drew that wrong, is actually, eraser going here, okay, is actually an element of, right, because this is actually inside the set. Okay, is 11 a subset of the set that contains 11? Yes. Is the number 0 in the null set? No, because nothing is in the null set. Is the null set an element of the set that contains the null set? Yes. Is the set that contains the null set an element of the set that contains the null set? No, that's not true. Is the null set an element of the null set? No. You can't say an element of something that's not a set, right? So when you're saying an element of, when you want to say 2 is an element of, that thing has to be in there, right? And it has to have set notation. There's no set notation on this side. All right. Almost done with this first page. Oh, actually, I better stop now because it's getting too long.